we are going to discuss about some of the problems on acceleration. From NCERT, right? So I will be taking first problem. So the problem number 1 is a student is there or a boy is there. He's throwing a ball with distance. The player throws a ball upward. The boy is throwing a ball upward with 29 meters per second. With the velocity 29 meters per second. 29.6. Right? Set 4. Right? The first question is asked that what is the direction of acceleration it has? Second question is what is the velocity and acceleration of ball at the highest point of motion? Velocity and acceleration of the ball at highest point. Third is it is saying that choose x equals to 0 and t equals to 2 location and the time of the ball at its x-axis. At highest point vertically downward direction to be the positive direction. So x equals to 0 and t equals to 0 at highest point and downward direction positive. Right? And at its axis and give sign of position. These are what is the sign of position, velocity and acceleration. In upward and downward direction. Right? These are the 3 questions, and the fourth is also there. That to what high the ball rises after So height h is past and time t of return if the hand of the player is passed, right? So this is the motion. We are sending a ball initially UH 29.4 meter per second. Now if at highest point V is 0. This is as taken as positive direction, right? According to this, at V equals to 0 and at t equals to 0. Right? V equals to 0, t equals to 0, that's it also. But V is final velocity, U is initial velocity, right? Remember that. Now it is asked, it is going from here to here and here to how much time it takes and what is the height it reaches and obviously. So let us go to one by one. First, what is the direction of acceleration? In downward direction. So remember the acceleration of gravity always works in the downward direction. So you must remember that this is a conservative, gravity is a conservative force field, but the one property which differentiates it from electromagnetic image, it is only attractive force, not the repulsive. It is only, so masses are only attract, they don't repel. Unlike the charges, right? So they always attract. So it's attractive force only. That's why acceleration of gravity always has only one direction, a downward direction. Correct? This is downward direction, and in the whether motion is upward or downward. But the motion, it is going up or downward. In both cases, it will always be in downward direction, acceleration. Question number second, it says velocity and acceleration about at the highest point. The highest point of acceleration is g, which is in downward direction again, and velocity is 0. Right? Third is how much? Third is at x equals to 0 and t equals to 0 at how highest point, downward direction positive, then sign of position. Remember the position is as it is moving downward direction or upward direction, it is always positive. Because displacement is always finite. So it's the positive. Positive in both cases. And velocity positive downward and negative upward. Why? It is decreasing and increasing. Right? Upward. And acceleration is always negative, independent of which direction we are moving. Right? So this is there. Our fourth problem is there, which we are going to discuss about. So what is the fourth problem? So it says that what is h and t? So h is, now you use this formula, b square equals to u square minus 2gh. Why are we using minus? Because acceleration is negative. motion is in upward direction, right? So v square equals to u square minus 2gh, right? So this v is 0 and is 29.4 whole square. This is 2 into 9.8 into h, right? So h is how much? 29.4 whole square divided by 2 into 9.8. This is how much? To simplify it, it is 29.4 multiplied by 29.4 divided by 2 into 9.8. 9.8, this gives you 3 multiplied by 2, divided by 2. So 29.4 into 3 divided by 2, it is 44.1. Right? This is the height, meter. Now how much is the time taken? We use another formula, h equals to ut minus half gt square. Right? Okay, this formula may not be useful here. We need a simple formula. This is useful, but it makes things complicated. So let us use a simple formula. What is simple formula? V equals to u minus gt. Right? Now V 0. So 0 equals to u, which is 29.4, right? Minus 9.8 into t. So t is how much? 29.4 divided by 9.8. Now this is not complete, remember that. This is better than let us write it capital T here. This is which considers upward and downward both. So this 3 seconds. So it takes 3 seconds to reach from here to here, right? And so what does it mean? The total time taken from here to here will be equal, so it will be, so time taken will be 6 seconds, right? So this is our first problem. Right? Now let us go to another problem. So this will, the second problem is we are taking a graphical problem, and we will try to understand it in a better way. So what is the second problem? Problem number 2 says that there is a figure given here, right here. It's V and T graph. Right? And A, B, C and D 4 points are given. A is there, here, and then we have a smaller peak here with a sharper decay, right? And then go to C. C is there, D is there. Right? A, B, C and D. So these are the 4 points. Now if we look at it very carefully, this is a constant, this is, now we have 4 graphs are given. Sorry, 3 variational points are given. This is there. Right? This is the question we have got. It is asking so particle is moving in a constant direction. The first question is asked, in which interval is the average acceleration greatest in magnitude? The question first says, in which interval the average acceleration greatest in magnitude. The average acceleration greatest in magnitude. Right? This is the first question. Second question is, in which interval average speed is greatest? Third question is asked, choosing the positive direction as the constant direction of motion, give the sign of V and A in 3 intervals. Sign of V and A. Right? Velocity and acceleration. What are the accelerations at the point A, B, C, and D? So A, B, C, D, acceleration velocity. Right? So let us go to this problem one by one. First problem says, in which interval the average acceleration is greatest in magnitude. Now you see, this is velocity time graph. So velocity time graph will have, when it will give you acceleration, it gives you, its slope gives you the acceleration. So greater the slope, greater the acceleration, right? So if you observe it carefully, in which case you will have the greater acceleration? The third case, the second case. Greatest acceleration. Basically, it is a retardation and velocity is decreasing, right? Velocity is increasing, so this is downward. Greatest acceleration, right? The first answer will be point. This is point 1, 2, and 3, right? Greatest in magnitude. Why are we talking? They are saying that magnitude because it is retardation. Basically, it is decreasing. In which interval average speed is greatest? Now, average speed is greatest when speed is greatest, when velocity is greatest. This is the case when average speed is greatest. Right? This. So at D on top, this point. Speed greatest. Let us discuss this third part of this problem. So it says that choosing positive direction as the constant direction of motion, give the signs of the V, velocity and acceleration in the 3 intervals, right? So the answer is basically solution. The third part is, now you see, if V is always positive in all the three cases. It is positive, positive and positive. So V is always positive or greater than 0 in all the three cases. Whereas acceleration A is positive in first case, this is third case, and this is second case. So A is positive in first and third case. You can see that slope is positive. The slope is positive, if it is. So slope is positive, so velocity is increasing, positive slope. This one also. So positive slope leads to the increase in velocity, so positive acceleration. This is the negative slope. So this is a retardation, and it is decreasing. Right? So at point A less than 0, at 3, at 2. Right? So this is the. Now let us go to the part 4. The part 4 says, so what are the accelerations at the point A, B, C and D? So A, B, C and D. And if you see it carefully, the change in velocity at all points is almost 0 because they are all straight lines. Slope is 0. Slope is 0. It means that acceleration is also 0 at all. At A, B, C, D. No change in velocity, acceleration is 0. Right? So this is all we have in this problem number 2 on acceleration. Now we will discuss other topics in the upcoming lecture.